Okay, so isosceles triangles, like the picture on the screen. My pen's not working. Why is the pen not working? Okay, so there are two congruent sides called legs. The angle where the legs intersect is called the vertex angle. The side opposite the vertex angle is called the base. And the angles along the base are called base angles. So it's about position. Just like several other things that we've done so far, it's all about position and order. So as you look at this diagram, I want you to look at angles 2 and 3 because those are the ones that are congruent. So notice where they are in relation to the two lines that are congruent, as well as where they are in relation to the vertex. So this is the vertex and these are the legs. Notice that, kind of like shoes, the vertex are at the bottom of the legs. Those are the things that are the same. That's what you need to remember. If two sides of a triangle are congruent, then the angles at the opposite of those sides are congruent. So if I tell you the sides are congruent, if AB is congruent to CB, then angle 2 is congruent to angle 3. Notice the order. The sides first, then the angles. But it doesn't change if we go the other way. If I tell you that the triangle has two congruent angles, so if I tell you that 2 is congruent to angle 3, angle 2, then you know the sides are congruent. So I don't have to mark both. So I don't need to mark both. If I tell you a triangle has two congruent sides, then you know the angles. But if I only tell you the angles are congruent, then you know something about the sides. I don't have to mark them both. So what you need to focus on is what this looks like as far as where the sides are. And so maybe you do just make it look like it's got feet or ears or something. These are called legs, so give it some feet. And where the feet are is where the angles are. Maybe they're pigeon-toed. Toes turn inward. So that's what this is. At the end of the two congruent sides, and since there's two angles, it can't be at this end because I need two angles and there's only one angle there. So at the end of the two congruent sides are two congruent angles. So when I look at this, when we look at the first question, what do I know about that triangle? As soon as I see this symbol, okay, so where is the other, which angle is, where are the two congruent angles? Which letters are congruent? J and L. That's all you have to do. Yes, these are isosceles. So that means that this is 68. So then how do I find K? 180 minus 68 minus 68 is 44 degrees. I know that it seems like a lot to have to write this down. But if you subtract wrong, and sometimes you do, I don't have any way to understand why it's incorrect if you don't write it down. Like I had one student who the given angle was 58. And for whatever reason, they put 60 in all of their math problems. But at least I could see that they were doing all the math right. They just, I don't know why, they went from 58 to 60.
Is this going to be on the test or is this just practice?
No, this is the test. All three days of triangle properties will be on the test.
What is this? Easy.
It is.
Hopefully.
Yes, keep saying that. It's easy. All right, so let's look at this one. Which two are the same? C and E. So now that I know that these two are the ones that are congruent, how do I find them?
I didn't get that.
Oh, shut up, Siri.
Is it 180 minus 106?
It is, so we'll start with that. 180 minus 106 equals 74. Then what?
Divided by 2?
Why do you divide by 2?
Because there's 2.
Because there's 2. So then we divide by 2, and I get that C equals E equals 37 degrees. So if I give you the vertex angle, then you subtract from 180 and then divide by 2, because whatever you have has to be split evenly between those two angles. If I give you one of the base angles, then you know it's this, and then you subtract those and get the other one. Now, pay attention to what it's asking you. So first it says to find this side, y, z. How much is that side? This is a side, not an angle. So how long is that side?
77?
That's an angle. That's an angle.
12.
12. Because since these are my two congruent angles, these are my two congruent sides. So this is 12. And then to find y, 180 minus 77 minus 77 is 26 degrees. Now looking at these two numbers, can you see why it's important that you put this degree symbol? Because this is not an angle, but this one is. And so I want to make sure that you recognize which one is which. I also had some students switch. They put X is 50 and Y is 55 when it should have been the other way around. So you just want to be careful when writing the units helps you do that. So technically, I guess we should put centimeters. What do I do with this? So I know where where the sides are congruent. Where are the angles congruent? The two at the bottom. These two are the same, right? And what is the symbol for same in math? Equals. When it's an equation, it's equals. So then we put 5x plus 9 equals 8x minus 30. Once we get to this point, the math isn't difficult. It's knowing whether they're equal or do I need to subtract from 180? Like, what do I need to do with those? And so it's all about knowing the relationship so that you can set them equal. So then we subtract 5x. 9 equals 3x minus 30. Then we add 30. 39 equals 3x. And then we divide. 13 is x. So what you're learning, the part that's new here, is what to do with these two expressions. They are equal because it's an isosceles triangle. That's the only way you know that. If you can recognize, well, those are the same, that means those are the same, so then I can do that. That's what it is. How about this one?
4x plus 7 equals 9x minus 13.
again, because these sides are congruent, so are these angles. That's the only way you know that is if you understand that property. Because if I draw this triangle and put 3x and 2x minus 9, you can't do anything. I've given you no information about that triangle. Nothing's marked congruent, nothing's marked the same. So you can't do anything. The only way that I know what to do on this triangle is because of those two marks. So because this triangle doesn't have any, I can't do anything with it. All right, let's look at, how about this one? What's marked congruent?
The angles.
The angles. And since the angles are congruent, what do we know about the sides?
They're also congruent.
They're also congruent. That means I can draw this, and then I can put 15x plus 7 equals 23x minus 17. Notice the difference in the way the triangles are laid out. Get used to looking at these. Like here it is with the vertex forward. This is the vertex on the right. This is the vertex, I don't know, leftish or rightish. Here's one upside down. It's not that it changes anything. It changes how you visualize it. So when you look at number 7, is anything marked congruent? Like there are no little tick marks, but Jesus, you said
74.
they're both 74, right? That's the same as saying they're the same because they're both the same number, right? So even though it's not marked with this little symbol, like I have been doing, or the things, 74 is 74. So it has two congruent angles. So that tells me that my sides are congruent. So then I get 9x minus 73 equals 3x plus 23. Now, here comes the real understanding, because now you got words. I know, words are awful. Okay, so first of all, I have a triangle, okay? And this is the order, so it goes RST, and I always just go clockwise. So RST, okay? Now, I drew it weird, but where does it say the two sides are congruent? So it doesn't matter how you do it, it just matters how you mark it. So it doesn't matter that it doesn't look like that. Those are the two sides that are congruent. So where are the two angles that are congruent? Which letters? S and R. These are the two that are congruent. That's important because I'm giving you value, so you have to know where they go. You have to know what to do with these different expressions, because there's 3 of them there, which ones are equal and which ones are not. Now, I give you 3 angles, so I could do this a couple different ways. I could either say that angle R equals angle S, right? Or I can say angle R plus angle S plus angle T equals 180 degrees. I can do either one. Either one will give me X, and then I can substitute it back in. Which one seems easier? The R equals S? It's probably the same thing, but you can use either property. So let's use R equals S. So 9x plus 2 equals 13x minus 18 minus 9x, add 18, 20 equals 4x, x is 5. Okay, so x is 5. So now that I have x is 5, Now I can just substitute that back in. So 9 times 5 plus 2, 13 times 5 minus 18, and 17 times 5 plus 1. I think 17 times 5 is 65. Yep, plus 1. So 66. 60 minus 18 is 42. And 45, 47. Okay, something's wrong. Oh, it's 65. 65 minus 18 is 47. Okay, how did I know that something was wrong? Two of them have to be the same. Are they the same? No. So make sure that when you do your math, don't be like me, use a calculator. So R is 47, S is 47, and T is 86. What did I put? Why did I put 66? It's supposed to be 86. Somebody stop me when I make, that's why I have a spelling bee thing on. Stop me when I make math mistakes too. 86. Now, I could have done the same thing here. When I solved this, I still would have gotten x was 5. And then I would have just substituted back into the 3 expressions. So it doesn't matter which one you do. It just matters which one you know to be correct. All right, let's look at it says D is equal to E. That means we put F up there. So D is equal to E. And it says that DE is x plus 4. EF is 4x minus 8. And DF is 7x minus 35. Now, unless I give you the perimeter, which I don't in this question, the only way you know what to do is if you understand that because these angles are congruent, these legs are congruent. So the only way that you can solve this problem is if you know about isosceles triangles. So then I can say 7x minus, let me move that a little bit. 7x minus 35 equals 4x minus 8. So I'm going to subtract 4x from both sides and add 35 to both sides. So I get 3x equals 27. X is 9. What you are learning, like hopefully at this point in your math career, you know how to solve the equation. It's how to write the equation, what you can set equal that you're learning in this section. Are they all the same? Are only 2 of them the same? Or like, how do you know what to do? So then we go back to our expressions. And so this is 9 plus 4, that's 13. This is 4 times 9 minus 8, that's 28. And this is 7 times 9 minus 35, that's 28. And so that's how we find our sides. Notice that there's no degree symbol here. We're being accurate. These aren't angles. Okay. A little bit about equilateral triangles. In math, This is an important statement. If and only if. So when I was your age, my parents would tell me I was grounded. And that's supposed to be like the end of it, right? Except then I would go, please, please, please. And I'd clean my room and, do the dishes and whatever else I hadn't done. And I'd be super nice to my brothers for 5 minutes. And then I'd get to go out. So then grounded didn't mean grounded, right? It just meant till they weren't mad at me anymore. But if and only if means there's no other way to do this. There's no getting around it. There's no sucking up. If and only if. A triangle is equilateral if it is equal angular. So it has to be both. It has to be both equal sides and equal angle. It has to be both. You can't have one without the other. So what that means is that if A equals B equals C, so if all the angles are congruent, then AB equals BC equals CA. If all I do is mark the angles, then you know that all the sides are congruent. If all I do is mark the sides, then you know that all the angles are congruent. Angle A equals angle B equals angle C. Put the little M in there, it's more appropriate. So, like the first two are super easy. When you look at number 11, how much is angle C? 60? I'm going to let you in on a little secret. Equilateral triangles only have 60-degree angles. That's the only thing it can be. If they're all the same, the only thing that 18 divided by 3 is 6. So 180 degrees divided by 3 angles. All equilateral triangles have 60-degree angles. All 3. Now the sides can be different sides. So we found the angle. How long are the sides? Still for number 11. If the angles are congruent, what does that tell you about the sides? They are too. So how long are the other 2 sides? 9. That's it. Now, I promise that there won't be anything quite that easy on the test. But if you have an equilateral next to a different triangle, you still know lots of things about it. Yep. All right. Let's look at number 12. So first let's look at the 24. So the 24 tells me that one side is 24. So what are the other 2 sides? 24, super easy. How am I supposed to figure out what the angles are if I don't have any angles? What did I just tell you they always were? Always 60, even though there's nothing there to tell you except these marks. So there's no, like this one's 60, so the next one has to be 60. You just have to know that an equilateral triangle has 3 angles that are 60 degrees all the time. All right, last one. How am I supposed to do this? I don't have any values. The only way that you can solve this problem is if you know, it says it's an equilateral triangle right there. So as soon as I see that word, I go through and mark my sides and my angles. That tells me that all of my angles are the same and so are all of my sides. So now it doesn't matter which 2 I pick. I can solve for one side. So it doesn't matter. I'm just going to pick 2 of them. 11y minus 23 equals 9y plus 1. I know they're the same thing. I don't know what that thing is yet, but I know it's the same. So minus 9y plus 23. Notice that I cancel something on both sides. So that's 2y equals 24. Y is 12. That's all I asked you to find was y, not to plug it back in. Now I have this angle here, but I don't have anything to set it equal to. So what can I set it equal to? I have 7x minus 3. What does that equal? What's one angle in an equilateral triangle? 60. So these are all 60. You could write that in there if it helped you to remember. So then plus 3, 7x equals 63, x is 9. As you work through the problems today, please pay careful attention to where the congruent lines and therefore the congruent angles are. I think it would be good if you got in the habit of doing this. Like that's what it looks like, right? A pair of toes that are turned in. So get in the habit of doing that so that you can find the angles that are congruent.